Hi everyone, welcome back to this channel. In the previous class, we had discussion over the nomenclature of aldehydes, ketones and carboxylic acid. The aldehydes, ketones and carboxylic acids are nothing but the organic compound contains carbon, oxygen and hydrogen with carbon-oxygen double bond. The carbon-oxygen double bond compounds are also known as carbonyl compounds. These aldehydes, ketones and carboxylic acids belongs to the carbonyl compounds. The nomenclature contains two different ways. One is common naming system and another one is IUPAC system. In case of a common naming system, we use the different prefixes alpha, beta, gamma based on the substituent that substituted to the chain of the aldehydes and ketones. And in case of IUPAC system, as usual, we use the numbers for the substituted carbon. Let us discuss the nomenclature by considering the other different kinds of examples. Few examples we were discussed in the last class. Okay, the continued part of the nomenclature will be discussed today. The first, I would like to take a different types of a compound. If the aldehyde is cyclic, for a cyclic compounds, I am consider cyclohexane, the well-known compound cyclohexane. It is not a benzene, okay? There is no double bond. So all carbons are singly bonded, and there are 6 carbons. They are singly bonded and they are cyclic compounds. If it contains CHO, then what is the name of the compound? It is a type of aldehyde because we observe the aldehyde functional groups here because it is aldehyde. And what is the name of the compound? The name of the compound is cyclic compound, cyclo. How many carbon? 1, 2, 3, 4, 5, 6. Clearly observe. I am not consider this carbon for the counting. Okay. In cycle there are 6 carbon. Therefore hex. All are singly bonded. Cyclohexane. Next, the functional group is named as cyclohexane carbaldehyde. Cyclohexane carbaldehyde. Cyclohexane carbaldehyde is the name of the compound. If it is a penta or 5 carbon pentacyclic, so in that cases cyclopenta carbaldehyde. So similarly, we give the name for the cyclic compounds. If the same cyclocarbaldehyde derived or the one compound that derived from cyclohexane carbaldehyde contains methyl groups anywhere of the cycle, okay, anywhere. The substituted carbon is known as, during the common naming system, we use the prefixes alpha, beta, gamma and all that. In case of this compound, the carbon is attached carbon is known as alpha during the common naming system, and the adjacent carbons, how many carbons are there? There are 2 adjacent carbons here and here. This one is known as beta, again this one is also known as beta. The very next to beta is known as gamma carbon. Based on the position of the substituent that substituted to the cyclic compound, the name of the compound is the beta position of the cyclohexane contains methyl group. Therefore, it goes to prefix. Then the prefix become beta methyl. There is no space between methyl and cyclohexane. Beta methyl cyclohexane carbaldehyde. Name of the compound is beta methyl cyclohexane carbaldehyde. Similarly, we give the notation for the prefixes during the common naming system. Okay, for other substituent also. CH3 group is suppose attached to gamma, then it is gamma methyl cyclohexane carbaldehyde. So this is the way of naming the aldehydes in common naming system. Okay, suppose there is a question asked to write the IUPAC name of the same compound. What is the IUPAC name of this compound? Then we use the numbers. How to number the carbon? This is the first carbon and this is second carbon, this is the third carbon. Why this carbon is first carbon? Because according to the IUPAC system, the functional group carbon should be get least number. So you should get least number. The carbon should get least number means then start from this that carbon. So 1, 2, 3. So this is the way of numbering the carbon in case of aldehydes. The third carbon contains methyl, therefore 3-methyl cyclohexane carbaldehyde or hexanal. Okay, that also used during the IUPAC system, hexanal. Okay, 3-methyl cyclohexanal or 3-methyl cyclohexane carbaldehyde. Both name is accepted in case of a IUPAC system, but this is the best way of naming the aldehydes through IUPAC system. Okay, 3-methyl cyclohexanal. Okay, next. I would like to take ketones in the next part. Okay, and continue the naming system for aldehydes. I consider other examples. Suppose the example is like that: CH double bond CH2 double bond CHO. There is a particular common name for this compound. Okay, acrolein is the name of the common name of the compound. Acrolein is the common name of the compound, and the IUPAC system, in case of IUPAC system, the name of the acrolein is, how to name the aldehydes and compost. Select the long chain and select the long chain. Next, give the number. Is the first carbon, the second carbon, is the third carbon. So how many carbon in the compound? There are 3 carbon in the long chain. 1, 2, 3, and we use Al in case of aldehydes. It's a suffix. It contains one double bond. Here we observe the double bond. Therefore, the name of the compound is totally 3. Therefore, it is pro. There is a double bond on second carbon, pro 2 ene. This much is pro 2 ene. But here we observe the functional group. The functional group is aldehyde. Therefore, it is replaced by propanol or pro 2 ene 1 R. Both is correct. There is no need of mentioning the number 1 for aldehydes. The mentioning of 1 is not necessary in case of aldehyde, because it is understood the aldehyde is always present at the corner. Aldehyde always present at the corner. Ketone present in between the chain. Next, I am considering other example. CH3 CH OCH3 CHO. How many carbons are there in the long chain? So first select the long chain. There are two groups. One is aldehyde, another one is methoxy. Methoxy becomes substituent. Because of that reason, this is the prefix. This one is prefix, and the aldehyde is a higher priority functional group. A higher priority functional group Therefore, it is the first carbon, numbering the carbon in this way: 1, 2, 3, 4. This is the longest chain. The third carbon contains one substituent. The substituent is nothing but methoxy. Okay, it is the prefix 3-methoxy. 3-methoxy. 4 carbon, therefore bute. All are singly bonded. In E is replaced by R, butanol. 3-methoxy-butanol. Very simple. Okay, 3-methyl-butanol is the name of this compound. Next, CH3, CH, 1, 2, 3, 4, 5. Here I am writing the two substituents. Okay, one is Br, another one is CH3. Here 2, CH. Okay. What is the IUPAC name of this compound? Okay, here we have the one example. In case of aliphatic, it is a cyclic compound. The third example for aliphatic aldehydes. Next, first select the long chain. So according to the IUPAC rule, first select the long chain. This is the longest chain, contains more number of carbon and branches. Next, numbering the carbon. The numbering the carbon by considering the functional group. Functional group carbon is present here. Therefore, the 1, 2, 3, 4, 5. There are 5 carbons in the chain. Next, 4. On the 4th carbon, we observe the bromine, and the 3rd carbon contains methyl substituent. Both are substituents. Therefore, we go through the alphabetical order during the naming of this compound. By considering the alphabetical order, there are 2 prefix. One is bromo, another one is methyl. So which one comes first? Bromo comes first because B comes first. Therefore, the name of the compound is POR-. First letter should be capital. Bromo. There is no space between any words. 4-bromo. 3rd carbon contains methyl. Numbers are separated by hyphen. Next, small letter M. Methyl group. If it contains ethyl, then ethyl. Okay. E also comes after the B. 4-bromo, 3-methyl. Total number of carbon 1, 2, 3, 4, 5. 5. So therefore, for 5, the root word is pent, and contains alpentanol. Why we use AN? All are singly bonded. Therefore, AN. Okay. 4-bromo, 3-methyl, pentanol. So this is the IUPAC name of the compound. Next, in case of aromatic. For aromatic compounds, aromatic means derived from benzene ring. Suppose the benzene ring contains CHO. The benzene ring contains CHO. According to the IUPAC system, it is a benzenol. Correct? It's according to IUPAC system, it's a benzenol. Yes, it's correct. But there is another word. It is from common name benzaldehyde. This name is accepted in IUPAC system also. Therefore, this one is also correct. Okay. The benzaldehyde name is also correct for correct under the IUPAC system also. The derived compound from benzaldehydes all are suffixed as benzaldehydes. Okay, benzaldehyde is become the root word for the derivatives of benzaldehyde. Okay, so in case of the benzaldehyde, again for the aromatic compounds, how to name the compounds? Again, when we go through the common naming system, we use the positions. Our positions are ortho, meta, para. So here we observe the ortho position, here we observe the meta position and the para position. So for the naming of benzaldehyde, suppose it contains methyl here, then ortho-methyl benzaldehyde, here meta-methyl benzaldehyde, here para-methyl benzaldehyde. And in case of IUPAC system, we use the numbers. How to numbering the carbon? Here is 1, 2, 3, 4, 5, 6. Okay, but it is depends upon the substituent present on the carbon. If it contains only one substituent here or here, both the cases it is become 2-methyl. Okay, because suppose CH3 group is present on the left side of the benzaldehyde, we give the number from left side, and suppose it is present on the right side, we going through the right side. Therefore, there is no differences we observed during the numbering of the this aromatic compound contains 1 or 2 substituent, but contains more number of substituent. Then question arises, which one has higher priority and which comes to the lower priority? That it is according to the priority. Okay, suppose it contains like a methyl, here bromo, here there is another one hydroxy group is there, then the naming or the numbering of carbon should goes in this way, because hydroxy is a higher priority functional group and that. So this is about the benzaldehyde. Next, for aromatic compounds, case of aromatic compounds, we observed the 2 more other different compounds. The one compound, such compound is the benzene contains 2 aldehyde group, CHO, CHO. The common name of this compound is phthalate or phthalic acid. Sorry, phthalate. Phthalate. It contains CHO acids, then phthalic acid. Okay. Similarly, it contains CHO, then it is known as phthalic acid. It is aldehyde, phthalaldehyde. Okay. What is the common name of the compound? IUPAC is the name of the compound. The phthalaldehyde is the IUPAC name of the phthalaldehyde is contains 2 aldehyde groups adjacent of the adjacent carbons in the benzene ring. Therefore, it is 1, 2 benzaldehyde, or 1, 2 benzene, 1, 2 diol. Okay, diol. Next, here I am consider another one example, CHOOH. It is salicylaldehyde. Okay, the name of the compound is salicylaldehyde. Common name is salicylaldehyde, and the IUPAC name is contains hydroxy on ortho position, become 2, second carbon is the first carbon, second carbon, third carbon, sorry, the third carbon, 3 hydroxy. Why it become 3 hydroxy? Hydroxy is lower priority, aldehyde is higher priority functional group. Just you observe the first year notebook and once again recall which one comes first and which comes last and all that. What is the priority of the functional groups? Aldehyde has higher priority compared to alcoholic group, 3-hydroxy benzaldehyde. 3-hydroxy benzaldehyde. The question arises, if it contains ketone, if the long chain contains ketone. Here I am considering another one example for that. Here we observe the ketone RCO CH2CHO. Which one get more priority? According to the priority, aldehyde has higher priority than the ketone. Therefore, this first carbon, second carbon, third carbon, fourth carbon, and for the premix of ketones, the ketones become substituent. The substituent ketones is prefixed as oxy, 3-oxy-butanol. So this is the way of naming the aldehydes and aldehydes. Okay. Next we will discuss the ketones. Okay. So this is about the different types of aldehyde. Please practice more and more examples. Examples given in your different in CRT book as well as in your other reference books. We come across a lot of examples. So to solve the examples, and internet is also best source to collect the different examples. So I consider different types of examples, similar kind of examples, or this much example is enough to solve a different kind of IUPAC system of aldehydes. Okay. Next, I consider ketones. In case of ketones, O is used as a suffix. And consider few examples. One is CH3CO CH3. So this is nothing but acetone. Common name is acetone. IUPAC system of in IUPAC system, the acetone is named as, it is a 1, 2, 3 or 1, 2, 3. Both is correct. Okay. Total number of carbon is 3. Therefore it is pro. The second carbon contains one, pro-2-one. Propane-2-one. Propane-2-one. Why we use ane? Ane is because of singly bonded carbon. Propane-2-one. CH3, CH2 are here. Okay. CHCO, CH3, CH3, CH, CH3, CH3. Then what is the name of the compound? 1, 2, 3, 4, 5, 6, 7. The 7 carbon in the compound. Both the side we observe the 2 CH3 groups. CH3 groups present at the corner. Then we use the iso. Both the side we have observed iso, di-iso-heptanone. According to the common naming system, di-iso, 7 carbon, because of 7 carbon, hept, di-iso, hept, because of presence of the ketone, it is one. What is the IUPAC name of this compound? The IUPAC system, first we go through first we select the longest chain. The longest chain should contain the functional group. Yes, this is the way of selecting the long chain. So here we observe 1, 2, 3, 4, 5 carbons in the long chain. Therefore, it is the correct way. And numbering. Suppose we numbering from right to left, then we give the number for ketone. The ketonic carbon get the 3 number. And suppose we move from left to right, then again 3, both the way is correct. Therefore 1, 2, 3, 4, 5, this one is the correct way. And you can do the number in this way also, here, all way is correct. Next, the name of the compound is, how many carbons? There are 5 carbons. Second and fourth carbon contains methyl. 2, 4, how many? 2, dimethyl. 2, 4, dimethyl. pent. Why is pent? 5 carbon in the long chain. Long chain we observe the 5 carbons. So therefore it is 2,4 dimethyl pent singly bonded in the O present 1, 2, 3 on the third carbon. Pentane 3-one is the name of the compound. Please note it down. Okay, this type of question is very important. Sorry, this type of example is important for your exam point of view. Similar kind of question asked in your exam. 2,4 dimethyl pentane 3-one. Okay, next, structure of aldehydes and ketones, or better to call it carbonyl compounds. What is the structure of carbonyl compounds, and on what basis you can give the or explain the structure? The case of the carbonyl compounds, the carbon contains oxygen, correct? The carbon oxygen double bond is observed, and the carbon, the other valency of the carbon is satisfied by the sigma bond. Now, according to the bonding of the carbon or the hybridization of the carbon in the carbonyl compounds, the carbon is sp2 hybridized carbon. Carbon is sp2 hybridized carbon. In case of sp2 hybridized carbon, the 3 orbital that undergo formation of a sigma bond, 3 involved in the formation of sigma bond, and 1 p remains, 1 p orbital remains on carbon. It is that p orbital undergo lateral overlap with the p orbital of oxygen that present adjacent to the carbon. Because of that, there is a pi cloud. Pi cloud is observed around the sigma bond of carbon oxygen, and that leads to formation of a pi bond. So when we observe in a planar structure, in a planar, we observe the planar trigonal planar geometry with bond angle 120 degree. Here we observe 120 degree, here 120 degree, here also 120 degree. So 120 degree bond angle, because of the absence of lone pair of electrons. There is no lone pair. The fourth valency of the carbon, or the fourth one, p orbital, that involved in the formation of pi bond. Therefore, there are 3 sigma bond in carbonyl compounds or carbon. 3 sigma bonds and 1 pi bond is observed, and the bond angle is 120 degree, and trigonal planar structure is observed. Okay, so this is about the structure of carbonyl compounds. Carbonyl compounds means it is applicable to all the compounds, aldehyde, ketones and carboxylic acid. So this is about the structure. About structure, there is no question asked in your exam, but for your competitive exam purpose, the knowledge of the structure is very important for the further reactions and all that. Okay. Next, we move on to the preparation part. I would like to divide the preparation part of aldehyde ketones into 2 categories. Okay, in the first part, I will take the only preparation of aldehydes and ketones the common way. Okay, preparation of or common preparation of aldehydes and ketones. Aldehydes and ketones. Preparation of aldehydes and ketones. Only preparation of aldehydes, only preparation of ketones will be discussed in the next video. Okay. The preparation of aldehydes and ketones. The first method is from ozonolysis. I think this the same part you are studied in the first year. Ozonolysis of alkenes. Okay, better to hold it is like from alkenes. Okay, how to prepare aldehydes and ketones from alkenes. When alkenes are subjected to ozonolysis, then it gives an aldehyde. Okay. For example, when acetaldehyde, CH2 double bond CH2 and ethene, example is ethene, alkene. Okay, and consider the member of alkene. When alkene is subjected to ozonolysis, then first there is a formation of ozonoids. This ozone leads to formation of ozonoids by break down the both pi and sigma bonds. So intermediate is formed or transition state is observed. This is nothing but ozonoid. Ozonoid is formed and the corresponding ozonoid is formed. That corresponding ozonoids, that's next, in the presence of zinc or reducing agent, gives CHO formaldehyde from this carbon. Okay, how? This bond undergo cleavage, this bond comes to here, CH2S double bond. What type of compound it is? It is a nothing but aldehyde. C contains two hydrogen H2 and oxygen. Now it becomes double bond and this goes to this side. This oxygen goes to bond with the that involved in the oxidation of zinc. Okay, because of that two same compound is observed, CH2O, CH2O. So CH2O nothing but HCHO. What is the meaning? It's a formaldehyde. Formaldehyde is generated. So in another word or IUPAC name of the compound is, compound contains one carbon, therefore methanol. Please remember, this is a very important concept for your exam point of view. The conversion of ethene into methanol or preparation of methanol from ethene. How to prepare methanol from ethene? Using ozonolysis. Okay. So this type of reaction is very important. Please give more time to practice such type of reaction. Organic reactions are very important. Inorganic compounds or organic chemistry, aldehyde, ketones and carboxylic acid topic is very, very important. Okay, you should give more time to this part. It is needed. Okay, the methanol is produced. Then what kind of question asked in your exam? What are the different kinds? The first one is prepare methanol from ethene. This is one way of asking the question. And name the product formed after the ozonolysis of ethene. What is the ozonolysis? Ozonol is the product of ethene, nothing but methanol. Or prepare formaldehyde from alkene. Which alkene is suitable to prepare formaldehyde? So there are a lot of ways to ask the questions on the same reaction. Okay, and here we observe the another important thing. It is if we consider symmetrical alkene. This is symmetrical alkene because adjacent to the alkene or double bond we observe the two carbons, same number of carbons, so 1 carbons. It is a symmetrical carbon. If we use symmetrical carbon for the ozonolysis or the ozonolysis reaction, then always gives one kind of product. Only formaldehyde is produced. Only one kind of product is observed. If we consider the unsymmetrical, just imagine in the place of hydrogen there is another CH3. What is the product? What is the name of the product and what are the different kind of products is observed? Here we observe another CH3. Here we observe the CH3 in one compound. So one is methanol, another one is ethanol. So So if we consider propene, for the ozonolysis, then two kind of product, one is formaldehyde and one is acetaldehyde. Okay, that is the differences during the ozonolysis. Okay, these things are very important for your competitive exam also. Please practice more examples on ozonolysis. Definitely one question is asked in our competitive exams. Okay, next, the second method. Okay, second method of preparation is, first one is ozonolysis, second one is oxidation. Oxidation of alcohol. So better to got from alcohols. There are two ways. That part we will discuss this in alcohol topic. Same part. Oxidation of alcohols. How to get aldehyde after the oxidation of alcohol? When CH3, or better to call the primary alcohol. Okay. Primary alcohol means RCH2OH. Okay, the primary alcohol. When any primary alcohol is subjected to oxidation with the help of pyridinium chlorochromate. PCC. P stand for pyridine chlorochromate. When pyridine chlorochromate is used as an oxidizing agent for the primary alcohol, then that produce corresponding aldehyde, and if we use the secondary, then it gives the ketones. Okay. So it is depends upon the degree of the aldehyde. If we use the primary, then aldehyde is produced. If we use the secondary, then it gives the ketones. Suppose we use tertiary, there is no possible reactions. Okay, so these are again very important concept. Primary use aldehyde, secondary use ketones after the oxidation. Next, same from aldehyde. Okay, from alcohol, dehydrogenation. Dehydrogenation means removal of hydrogen. Okay, hydrogenation means addition of hydrogen or nothing but reduction. This dehydrogenation is nothing but oxidation of alcohol using a metal. This dehydrogenation is made or conducted. The dehydrogenation takes place only in presence of the metal like copper and silvers. When copper or silver catalyst is used for the oxidation of alcohol, then again it gives a aldehydes. When again same similar kind of reaction, but only the reagent is different. Reactant is same. Primary, I am considered primary. When primary is alcohol is heated around 573 Kelvin. Please remember the temperature is very important. 573 Kelvin in the presence of copper or silver, then it gives aldehyde. Corresponding aldehyde is produced. One example is a primary alcohol with aldehyde. I am consider ethanol CH3CH2OH. What is the name of the compound? Ethanol. Why it is ethanol? It is alcohol because of that all. When ethanol is heated at around 573 Kelvin in the presence of copper, then produce CH3CHO. Hydrogenation take place. Okay, hydrogen removes out. Okay, hydrogen gas is eliminated. This is nothing but ethanol. Okay, ethanol to ethanol. There may be a possibility asking the question on this or in this category reactions. What is the possibility? Prepare ethanol from ethanol. Which is the best way to prepare ethanol from ethanol? Or what is the product formed after the oxidation of ethanol? Or another possible question here using the question mark. Ethanol get converted into ethanol in the presence of dash, in the presence of copper or silver. Okay, so these are the very important concepts. In the next video, we will discuss the particular specific reaction of preparation of aldehydes and ketones. So this is the common preparation method. Okay, thank you for watching.